Okay. Now, let's do this next part. The regions of convergence and stability. The word region of convergence is talking about h of z, where z, the values of z that will make h of z not infinity. What do I mean? All right, let's begin with what are we going to do for this subpart. We are first going to define what is I've just defined what is ROC. We'll find the ROC for a finite sequence, for an infinite sequence, and then talk about how ROC is related to infinity. So, the word ROC means region of convergence. Region of what? Region of Z. What is Z? The complex number, not the complex number, the set of complex number. The values of complex number that will make, in this example, x of z not equals to infinity. Okay? All right. Let's try. In the simplest example, this guy, now I have x of n equals to 1, 2, 3, followed by sequences of 0. So this is a finite length sequence. Xn only have xn equals to 0, 1, 2, with the rest of the values 0. So this is a finite length sequence, and sometimes I put the arrow down, and then you realize that the little arrow stands for n equals to 0. I want to perform Z transform of a finite sequence. It's the easiest. I substitute the equation. The equation says x of z from x of n is this equation. And then I look up and I say, oh, n is only valid from 0 to 0, 1, and 2. Since n greater equals to 0, 1, 2, 3, all values equals to 0. Therefore, it is nothing but x of 0, z minus 0, plus x of 1, z minus 1, plus x of 2, z minus 2, and then I substitute x of 0, which is 1, plus second value 2, and third value 3. So this is, oh, sorry. So that's it. So let me ask you, what values of z will x of z not be equal to infinity? Which values of z that I substitute into this equation will make it not infinity? So if I substitute z equals to 1, what will happen? 1 plus 2 over 1 plus 3 over 1. Is it infinity? No. What about z equals to half? So it's 1 plus 2 over half plus 3 over half, right? Not infinity. In fact, almost every value that I substitute, z will not be infinity. But there's one value that when I substitute will become infinity. The value is z equals to 0. So when z equals to 0, x of z equals to infinity. For z not equals to 0, x of z is not equals to infinity. Correct? Yes? So the region of convergence is what? ROC is equals to set of z such that what? X of z is not equal to infinity. Can remember the word region of convergence means what are the value ROC? What values of z such that xz what is not equal to infinity? Can? So now the answer is all values of z except 0. So if I want to draw the region of convergence for this one, so I have x of z is equals to 1 plus 2. Yeah? But sometimes you all don't like to draw it like that, huh? Because we all don't know how to factorize in negative power. Huh? So what do I do now? Times z square. So means like this, right? Then now how? Z square plus, agree? Can? So now you also see, yeah, now you can see the pole, you can see the 0. So now, if I really want to draw, so now I will factorize this, which is equal to then if I want to draw, what do I do? This is the real number of z. In the middle is 0, right? This 0, not the pole and 0, 0. This guy is 1. This guy is 2. Minus 1. Minus 2. This guy j. This is minus j. This is the imaginary of the z, right? The plane. And now I want to draw the pole 0 diagram. And I got two guys sitting below. This guy are called pole, right? And what values will make the denominator equals to infinity? 0. So I will draw two poles. Two pole, right? One pole, two pole. At z equals to, correct? Can you see now? So no problem. So now I will draw a circle, the unit circle. So far okay? And now I will draw the two zeros. They are at minus 1, right? So the z equals to minus 1 minus j root 2. The other guy, minus 1 plus j root 2. So where is minus 1? Minus 1 is here. Root 2 is 1.414 here. Can you see? Can you see? Minus 1 root 2 minus. So this is minus 1 plus j root 2, right? This guy is minus 1 minus j root 2. Can? The pole, pole I draw it wrongly, guys. I should have drawn it as a x. So I have two poles. At z equals to 0. I have 1, 0 sitting at minus 1 minus root 2, minus 1 plus root 2, j root 2. Can? So this is the pole and 0 diagram. To find the factors of the quadratic, so we open up, let's try. Z plus 1 plus j root 2, z plus 1 minus j root 2. We open up, z square plus z minus j root 2, z plus 1 minus j root 2 plus z root 2 j plus j root 2 minus j square 2. And you keep on working, what do you get? All right, but we are here now. So what do we do? So I've reached here to try to explain one thing only. What is the ROC. What did we say previously? ROC is the Z values such that, ST such that x of Z is not equal to infinity. And the answer is every value except where? Yeah, which is the cross. Yeah, of course, cross means it goes to infinity. The rest of the value is not equal to 0. So I shade. How do you think I will shade? What did I shade? What am I shading? Correct. The gentleman is correct. The ROC is everywhere except Z equals to 0, because this is finite. All finite sequence, the region of convergence is the entire Z plane except Z equals to 0. The anti-causal sequence, also all Z plane except Z equals to infinity. Okay? So far okay? So in fact, here, including a 0. Here, left and right side, everywhere except Z equals to 0 and Z equals to infinity. So causal sequence, sorry, not finite length sequence are very nice. The H of Z is everywhere, yeah? Except Z equals to 0 or Z equals to infinity. But what about infinite sequences? When we have an infinite sequences, for example, the sequence never ends, just like this example, then it's actually very nice if we can just express it as 10 over 3, right? So you realize that actually when we represent in polynomial of numerator over denominator, we also can get a sequence of numbers like this, and now we have an infinite sequence. And this is the problem we're always solving, this guy versus this guy. This guy is a what kind of sequence? Yeah, so it's a finite length or infinite length? Infinite length because this guy go to infinity, half to infinity, half to n, so this guy will go on to infinity. Right hand side or left hand side? Right hand side, so it's causal. Left hand side because he go from -1 to minus infinity. Anti-causal. Is this equation and this equation the same? No, of course not, right? It's obviously different. But you realize that the Z transform is the same. Okay? However, the only difference between the Z transform is the ROC. Because how can two equations who looks different have the same Z transform? So something else must be different. Okay? So let's try. We have a Z transform of half n u n. Can? And half n u n looks like 1 half, 1/4, and so on. Agree? And this sequence go to infinite length. And when we try to apply this equation, x of z equals to we realize that we are stuck at this point. Correct? Because this guy goes to infinity. Never mind. This is the crucial step. We bring these two together. And we write it in this form. Again, half z minus 1. And then this looks like Yes. And in geometric series, it has a closed form that looks like such that for less than 1, right? But why? Why? So we have to find out why, right? Because, okay, so to find out why, we open up S of n, let S of n equals to the partial sum from n equals to 0 to big N. Can? That means it's equals to R0 plus R1 plus what? Until Rn. Agree? Now I will multiply Sn by Rsn equals to R1. Yes? And who will minus who? No? Top one minus bottom one. Sn minus Rsn equals to R0 minus or plus? Minus Rn plus 1. Agree? Now I will do Sn 1 minus R equals to R0 is what? 1. Agree so far? And only one more step to go. Sn equals to? Yes? Correct? Now, the only difficult thing is here, how to remove this guy. If R is less than 1, what happened to Rn plus 1 when big N tends to infinity? What happened? 0. Therefore, Sn equals to when N tends to infinity and less than correct? 1, right? 1, yeah? So what is R again? Okay, so R equals to half Z minus 1. So absolute of R is less than 1 means half over Z minus 1 means 1 over 2Z, right? Must be less than 1, implying Z must be, agree? Just move one side to the other side. Okay? Can? 1 over 2Z less than 1, right? If I want to multiply my right hand side by this, I must multiply my left hand side by this, right? Agree? And when I multiply, this one will cancel, right? And then, therefore, it means absolute value of Z is greater than half. Agree? Yes? What does absolute value of Z mean? What is Z again? Z is the complex number. Agree? What does absolute of Z mean? The length of a complex number. Yes? So if I'm now going to draw the circle for you, this is the imaginary part of Z. The real part of Z. This is 0, 1, minus 1, j. Agree? Where is half? Half is here, right? So now I'll draw a circle. for half. So all this is half. Can? Okay? What does it say? Z greater than half. Absolute value of Z greater than absolute value of half. Where? So all these set of Z such that, correct? Now you understand the region of convergence. Because, why? We need to reach this point. And we have just used this guy. Correct? Yeah? He tells you what are the value of Z that this equation is valid for. Convergence of what? An infinite series to become a closed form solution. Can you see now? Okay? So if you work it out, you realize, oh, okay, this is what it means. And then I draw the region of convergence outside half. Okay? Then I plot h of z, and it's very nice. This is a pole sitting at z equals to half. And the rest is the surface of h of z. This is the magnitude. Yeah? Because remember, x of z is a complex number. I will take the absolute value, which is the magnitude. Here is the dB scale, and I plot for you. All right. Now, what happened? The other guy, remember I told you the other guy also have the same x of z. Now, the equation is x of n equals to minus, so it's going down. Exists only from the left-hand side. When we keep on working, we reach this point. X of z looks exactly the same as our previous guy, except now the condition is different. The condition is here. And then if we look at the condition very carefully, it's different from our previous one. Here is a minus 1 z, means z over a is less than 1. Z over a less than 1 means z, absolute value of z, is less than a. Here is the difference. And now we see z, absolute value of z, is less than half. Because, hey, this guy is a anti-causal sequence. We already tell you, anti-causal sequence, the region of convergence is inside the pole. We find the pole, we shade it inside the pole. The other guy, we find a pole, we shade it outside the pole. Okay? Just remember it this way. If the sequence is on the right-hand side, the region of convergence is external to the pole. External to which pole? The largest pole. Okay? So if you have 3 poles, you go and find the one furthest away from the origin. Then you draw. Okay? Technically, it's every pole, region of convergence is outside. But we are interested in the intersection of all the poles, region of convergence. That's why we find the furthest one and we draw. If the sequence is left-hand side or called anti-causal, then we find the pole nearest to the origin and shade him inside. Okay? If the sequence is right-hand side and left-hand side, then one of them will be outside, one of them will be inside. And we now hope that this region of convergence also include the unit circle. Because when the region of convergence include the unit circle, what happens? The system is stable. So if this is h of n, this guy is always stable. So finite impulse response is always stable. That's why we love finite impulse response filter. Always stable. Never blow up in our face. Why? Because we clap. We send an impulse. After a while, he dies. Of course, he's stable. Yeah? Impulse response is absolutely summable. Sure stable because he dies. So this also tells us. This guy also stable. This guy also stable. Yeah? Even though causal and anti-causal. This guy, we better hope that when we shade, he also include the unit circle. Okay? If you don't include a unit circle, you will see that the sequence blows up. Can? Clear, guys?